and today we'll go and we'll see one of the important topic that is related to mathematical logic, and that is called as a predicate logic. And many students told me that they are struggling with the predicate logic concept because they don't know the basic concept of a predicate. So let's go and let's try to discuss about this the question or the things that we are having, which is called as what? Which is called as a predicate logic. So let's go and let's talk about is basically what is called as a predicate logic, what is the concepts that is related to predicate logic, to each and every particular concepts that is related to this. Yes, and thank you so much for coming on this particular session. So I welcome all of you on India's largest learning platform, which is nothing but Gradeup, and we'll go and we'll talk about it, and that is called as what? That is called as a predicate logic. Yes, good afternoon to all. But before that, let me tell you about myself. My name is Satish Yadav, and I have taught more than 8 years. I have taught for more than 8 years, and I have trained more than 1 lakh of students. And my areas of expertise are discrete mathematics, DBMS, ICT, and then digital logic. Okay, fine. So here let's talk about the study plan that Gradeup is providing. See, many times the students are facing a problem such that nobody is there to give a solution or a strategy such that how the students or how a person will be approaching, which is nothing but how this person can be planning the study for a whole year. See, most of the time the student does not have the idea such that how this person is going to plan each and every type of sessions that is going to be important. So here the Gradeup is providing you all the different kind of scenarios that is going to be possible. So here you will be having a 600 hours of live classes, you will be having a 5,000 of practice questions and hundreds of mock tests and hundreds of chapter wise notes. So if you want to have if you want to have, which is nothing but any doubt or something, then you can call on this particular number, that is nothing but 9650052904, and I can assure you that our team will help you in a best possible way. Okay, so if you want to go and if you want to take a subscription, you can contact on this particular number, that is nothing but 9650052904. Okay, this is related to the batch details. And obviously, see, the Gradeup, the best part about the Gradeup is basically, okay, Gradeup is giving you the whole year study plan, so that on Monday you will have a 2 hours class, on a Tuesday you will have a 2 hours class. So for a whole day you can plan your whole study, you can do a revision, you can solve a large amount of questions. So everything is going to be very beneficial if you will be joining the Gradeup. Okay, there are certain courses that are the Gradeup is following launching, and as you can see that the Gradeup is also starting one Hindi GATE series that is also going to be very beneficial that you people can have over here. Okay, so that is nothing but Vision GATE 2022 Hindi course for GATE CS. And yes, as I told you, in order to go and in order to understand the other things, you can contact on that particular number. Okay, let's talk about the other session. So if you want to learn about more, you can also download the Gradeup app, and the other faculties are also taking the classes, and that is absolutely free on a Gradeup app batch. So what you have to do, first thing, download the Gradeup app, and then there you can just click on your goal, that is GATE and CSE, and then you people can follow all of the free classes that every day the other faculties, the respected faculties, they are taking it. Okay, so let's go and let's talk about the today's concept, and that is nothing but the predicate logic. So let's go and let's try to start from here. See, as I told you, the first thing that we have to understand is basically, if I will write one statement here, let's consider if I will write x is even number. Okay, that's a very simple concept, but still, if I will write this statement x is even number, and if I will tell you, can you define the truth value of this statement, then you will say that, sir, I cannot define the truth value of this statement. Then I will ask why you cannot define the truth value of this statement. Then you will say that, sir, because we don't know the value of x. Then I will ask you, what will happen if I will provide you the value of x? Then can you define that truth value of this statement? Then you will say that, sir, we'll see. Okay, let's go and let's try to change the value of x. Suppose if I will change the value of x as 0, and if I will be writing 0 is even number. Now if I will tell you, can you define the truth value of this statement? Then you will say, yes, definitely we can define the truth value of this statement. Then I'll ask that, what is the difference between here and here? Then you will say that, sir, you already told us in a mathematical logic, directly we can define the truth value of a simple statement. Yes, that is sure. See, in a mathematics, always remember one thing, in mathematical logic, we can define the truth value. In mathematical logic, we can define the truth value, which is nothing but directly to a simple statement. So here, this is a simple statement. 0 is even number. Basically, it is a simple statement. So we can define the truth value of this statement. Sir, why we cannot define the truth value of here? X is even number. Then I'll say that X is even number is not a simple statement. This is a simple statement. So when you can define the truth value directly, that is called as a simple statement. Sir, my doubt is what kind of statement is this? This type of statements are called as what? This type of statements are called as a open statement. Okay, this type of statements are called as a open statement. So what is a open statement? Open statement, it is a type of statement. Open statement, it is a type of statement such that we cannot define directly the truth value. But when we will provide the input to this, it changes to simple statement. Sir, what is the meaning of that? Let's consider here. Here you will have an open statement. If anybody asks what is the open statement, then you have to say that open statement, it is a type of statement such that we cannot define directly truth value. You cannot define directly the truth value. For example, if I will be asking x square is greater than or equal to 0, then you will say that here you cannot define directly the truth value of this statement. What will happen if I will be writing x square plus y square is less than or equal to 0? Then if I will say that can you define directly the truth value, you cannot define it. You know why? Because these all types are called as an open statement. These all are things are called as an open statement. So what is an open statement? Open statement, it is a type of statement such that we cannot directly define the truth value, but when we will provide input to this, it changes to simple statement, and here we can define the truth value, right? That type of statements are called as what? That type of statements are called as an open statement. And one example is x square is less than or equal to 0, x square is greater than or equal to 0. Okay, that is nothing but called as an open statement. Okay, sir, I understood basically what is the open statement and I got the idea. Sir, what will happen if I will provide another input? If you will provide another input, you will be getting another simple type of statement. So again, that is nothing but simple statement 1. Here you will be having the simple statement 2. So till now I told you only one thing, what is called as an open statement. Now let me tell you something else. Sir, I am having a doubt from where we are taking this input. You are taking this input from a collection of elements. So this collection is called as what? This collection is called as a domain. So here you will be having what? Here you will be having this collection is called as a domain. So if somebody asks what is a domain, then you have to say that domain is basically defined as the set of possibility for an open statement or element of a possibility for an open statement. So you are taking the input from here, you are putting into open statement, and open statement changes to simple statement. So domain is basically set of possibilities for open statement. Okay, either you can call as a domain. There is another word that we can also define, that is called as a domain or a domain of discourse or universe of discourse. These all are different names that you people can have. And what is a domain? Either you call as a domain or you can also call as a domain of discourse. These all are different name for the domain of discourse, or you can also call as a universe of discourse. You can also call as a universe of discourse. These all are different name that you people will be having with respect to the domain. So I defined two things. One is called as the open statement. Second thing is called as a domain. So I defined two things. Now, sir, my doubt is why it is called as what? Why it is called as a predicate logic. So let's focus on that. Why it is called as a predicate logic. See, if I am writing the statement x is even number, suppose if I will write this statement x is even number, then I can say that if I am writing this statement x is even number, you must be knowing that every English statement is basically made up of two things. One is called as a subject, other one is called as a predicate. For example, Ram is eating rasam, Shyam is eating rasam, Sita is eating rasam, Geeta is eating rasam. This is called as an English statement. And we know that every English statement is made up of two things, subject and predicate. Your subject keep on changing, but your predicate does not changes. So here also the same thing will also be happening, which is nothing but x is called as a subject while even number is basically called as a predicate. So your subjects keep on changing while the predicate will remain same. One example, what will happen if I will write 0 is even number? As everybody can see that here x Now this changes to what? The subject. Your subject is changing. X will become a 0. So here we can have 0 is even number. Okay, 0 is even number. So 0 will become what? The 0 will become your subject. It keeps on changing. Now what will happen if I will be writing 1 is even number? See, this is also open statement, but the truth value is basically false, and here the truth value is basically true. So this is the concept related why it is called as a predicate logic. The type of logic that we are learning with respect to the open statement is called as a predicate logic. Okay, I told you three things: open statement, what is the domain, and third thing, what is called as a predicate logic. Now let's go and let's try to define the other terms that is very important here. And what is that? See, if I will give you one input, it changes to one simple statement, and we know that we have to use one variable to define it, right? That's how P, Q, R, S, T, we are using the variables in mathematical logic. When I'm having the open statement, when I will provide one input, it changes to one simple statement. And then here I will be having P, and then P is basically a variable which is used for this simple statement. Now let's consider here I will be having a Q, and Q is another variable which I have been used, which is nothing but 1 is even number. Suppose if your domain consisting of 4 elements, you will get 4 different type of simple statement, and you will require 4 different types of variables to assign it. What will happen if your domain consisting of 10 number of elements? You will get 10 simple type of statements, and you will require 10 different types of variables in order to assign it. Up to 4 elements, up to 10 elements, up to 100 elements, it is fine. But what will happen if a domain consisting of large amount of elements? If a domain consisting of large amount of elements, then it will become out of handy. It will become a tedious thing to go and to use 100 different types of variables. So predicate logic is saying that don't use the thousands of variables. Don't use hundreds of variables. Try to go with the minimum. So instead of doing that, what we are doing, we are going and we are trying to use, which is nothing but the other thing that is called as a predicate variable. So here this is the third thing that I am defining, and that is called as a predicate variable. Open statement I have defined, domain I have defined, the third thing that is called as a predicate variable. So P of X, now you don't require the hundreds of variables. What you can do is basically with the help of one variable, you can define everything. So here you will be getting P of X. Now what will happen if I will change the value of X as 0? So here the same variable can easily adjust, which is nothing but P of 0. P of 0 is a predicate variable which is used for this simple statement here. Now if you will change to 1, here you will be getting P of 1. That is nothing but the another variable that you people will be having with respect to this. That is nothing but 1 is even number. So in this way I have defined 3 things. What is that? Open statement, domain, and predicate variable. So 3 things are there. Sir, every 5 minutes you are defining a new term, which is important for this. But why you are defining it? I am defining because I want to find out the truth value of the open statement. As we know that in mathematical logic, directly we can define the truth value for a simple statement. But for an open statement, how we can define the truth value? So in order to define the truth value of an open statement, we will require the certain things. So that's why I have defined the open statement, domain, and predicate variable. Now let's move to the other thing. Suppose if I will be having something over here such that if my domain consisting of 4 elements, let's consider 1, 2, 3 and 4. If my domain consisting of a 4 number of elements, 1, 2, 3, 4, then I will have a time and I will go and I will ask, are you true or not? For example, my open statement is, let's consider X is even number. Suppose if my open statement defines that X is even number, and if I am having a 4 element, I will take one element, I will put it here such that 1 is even number, it changes to simple statement. And then I can find out, are you true or not? I mean, you true or not? Third one, 4th element is true or not? 3rd element is true or not? If my domain consisting of 3 to 4 elements, it's very easy to go and ask to each and every element, are you true or not? Are you true or not? Are you true or not? if my domain consisting of 10 number of elements, I will go and I will ask, are you true or not? But what will happen if my domain consisting of large amount of elements? If my domain consisting of thousands of elements, then it will become a tedious. We cannot go and we cannot ask to each and every element, are you true or not? Are you true or not? Are you true or not? So instead of doing it, what I will do, I will stand outside and I will ask in terms of quantity. I will be asking in terms of a quantity, check whether all of them are true or not. Check whether some of them are true or not. So here basically you are asking in terms of a quantity. The same thing also applies. Suppose if I am in a class and there are 4 students, and if I want to ask them, all of you have done your break, or if there are 4 students and I will go and I will ask to each and every student, you have done the breakfast or not? Breakfast is over, breakfast is over. If there are 4 students, it is very much possible to go and to ask to each and every student. But what will happen if a batch size is about 400 students? So I cannot spend whole time to go and ask to each and every student, done the breakfast, done the breakfast, you done the breakfast, you done the breakfast. It will require a lot of time. So what I will do, instead of asking to each and every person or a student, I will be asking in terms of a quantity. I will take a mic and I will ask, all of you have done the breakfast or not, or at least some of you have done the breakfast or not. So when you are asking in terms of a quantity, then we will require the another term, and that term is called as what? That term is called as a quantifier. So if anybody asks that what is a quantifier, then you have to say that when someone is asking the truth value in terms of a quantity. So quantifier is basically a tool. Okay, it is basically a tool when we are asking something in terms of a quantity. So when you people are asking something in terms of a quantity, that is called as what? That is called as a quantifier. So quantifier is basically what? Quantifier is basically a tool when we are asking something in terms of what? When we are asking something in terms of a quantity. So it is a tool in order to find out the truth value when you want to find out, when you are asking in terms of what? When you are asking in terms of a quantity. So basically in our syllabus we are asking either in terms of check whether all elements are true or not, or check whether some elements are true or not. So there is a special type of tool that we are using when all of them are true or not. There is a special type of tool when we are asking some of them are true or not. So when we are asking all of them are true or not, then we will require that tool, and that tool is called as a universal quantifier. So here you will be having what? Universal quantifier. Now let's talk about the sum. So when you are asking something in terms of a sum, that is called as what? That is called as the existential quantifier. So here you will be having what? Here you will be having existential quantifier. So one is called as a universal quantifier, another one is called as the existential quantifier. I hope you people are getting it. It's a very simple concept but very powerful concept. So quantifier, what is a quantifier? The quantifier is basically a tool when we want to find out the truth value in terms of a quantity. So we mostly go and ask in terms of a quantity when we are asking in terms of all. So when you are asking in terms of all, we are required the universal quantifier. So universal quantifier, it is a tool when you want to find out the truth value with respect to all the elements. Existential quantifier, it is a tool when you want to find out the truth value with respect to some element. Let's go and let's talk about first universal quantifier and existential quantifier. So whenever I will write the universal quantifier, then you have to think it is a tool for a truth value for all the elements. It is a tool for a truth value for a some element. So these two things you have to consider. Now suppose if you are having the universal quantifier, so let's consider here you will be having what? Here you will be having the universal quantifier. Let's consider this is your universal quantifier. So universal quantifier is having a representation. The representation is like that. Okay. Now how to read it, that is also very important. So suppose if you will be having something like that, then how to read it? It says that for all of x such that p of x. For every x such that p of x. For all of x such that p of x. Such that p of x. For all of x such that p of x. So in this way we are actually reading it. Now when the universal quantifier will become a true, try to understand. For all of x, p of x, when it will become a true, it will become a true when it is going to be true for all the elements. So all elements has to be true, then only it will become true. All elements must be true. All elements must be true. Then that is called as what? That is called as a universal quantifier. And then it will become what? It will become true over here. Now let's see that when it will become a false. So it will become a false when it will see at least one element is false. So here this is true, no problem. This is true, no problem. This is true, no problem. As soon as it will see at least one element, as soon as it will see at least one element, then it will become what? It will become a false. So here this is the thing that you have to understand. Universal quantifier. What is universal quantifier? Universal quantifier is basically a tool when you are asking the truth value in terms of what? Universal quantifier is basically a tool that you are asking something in terms of what? All. How to read it? I have written. When it will become a true? When all element must be true. When it will become a false? When at least one element is going to be true. Now, as I told you, I have defined certain things. Now we can define the truth value of an open statement. So I defined open statement, I defined domain, I defined the predicate variable, and I have defined the quantifier. Now it's time to go and time to find out which is nothing but what? Which is nothing but it is going to be when it is going to be true and when it is going to be false. Okay. So let's go and let's try to see that. When it will become a true and when it will become a false. Let's take example. Suppose if I'm taking my open statement as a predicate variable as a p of x, and here I will be getting x square is greater than or equal to 0. Now let's consider the domain is basically the set of integers. Now I want to find out the truth value for all of x p of x, or another way of writing for all of x such that x square is greater than or equal to 0. So as I told you, now can you define the truth value with respect to this statement? Yes, you can define the truth value with respect to this statement. And what should be the values? The values is going to be true. So when it will become a true? When all elements are going to be true. Then only we can say that it is going to be true. When it will become a false? When at least one element is going to be false, then it will become a false. For example, suppose if I will change the statements. Suppose if I will change this statement such that p of x is basically x square is greater than of 0. Now my domain is basically the set of integers. So here if I am writing for all of x and then p of x, then another way of writing for all of x, x square is greater than of 0. See, it will be true for each and every element. But what about 0? Hence this statement will become what? This statement will become false here. So as I told you, which is nothing but when it will become a true, when it will become a false, try to understand. When it will become a true, it will become a true when all element must be true. When it will become a false, when at least one element will see the false, then the statement will become a false. This is a concept that is related to what? That is related to which is nothing but called as a quantifier. Now let's go and let's talk about the other things that is important over here. And what is that? That is nothing but the existential quantifier. So the other term that you have to understand is basically called as the existential quantifier. So if somebody asks that what is the existential quantifier, then existential quantifier is basically defining as what? Such that like this. Okay. So if somebody asks what is the existential quantifier, then you have to say that existential quantifier is basically a tool when we are asking the truth value in terms of some element, in terms of few elements. How to read it? That is very important. So it says that there exists x such that p of x. So how to read it? Reading is very important. There exists x such that p of x. Such that p of x. Okay, there exists x such that p of x. That is related to existential quantifier, or there are at least some value of x where it will become true. Now let's go and let's try to see that when there exists of x, p of x, it is going to be true. So let's consider this is our domain. When it will see at least one element, when it will see at least one element as a true, when it will see at least one element as true, at least one element true, then the whole statement will become a true. then this whole statement will become what? True. The whole statement will become a true. So there exists of x, p of x, when it will become a true, when at least one element is going to be true, then only it will become a true. Now let's talk about when it will become a false. When it will become a false here. So here if you will take this domain, so what it is trying to say that when it will become a false, there exists of x, p of x, it will become a false when all elements are false. Every element has to be a false. When all elements are false, this is also false, this is also false, this is also false, this is also false, when all elements are false. When all elements are false, okay? So that is a concept of what? That is a concept of existential quantifier. When all elements are false, then we can say that it is going to be what? It is going to be a false. When it will become a true, when it will see at least one element is true. So can you understand inside story of a there exists, you can say that there is OR case. OR case will be available. You know why? Because it will see at least one true, whole statement will become a true. Or, in this way you can understand. Inside there exists, you will be getting what? You will be getting OR case. Inside here, you will be getting OR case. But what about for all? For all, you will be getting the AND case. So that is very important here. Let's see the example that is related to this. Suppose if I am writing, my domain is basically, which is nothing but 1, this is 2, this is 3, this is 4. Now, if I am writing which is nothing but what? Which is nothing but p of x and such that x square is equals to 4. Now, if I want to find out the truth value of this such that x square equals to 4. So, we know that when it will become a true, when at least one element will become a true. So here if you will put x equals to 1, you will get 1 square equals to 4, which is false. When you will put x equals to 2, you will be getting 2 square, that you will be getting as a 4, and then hence it will require at least one element that is going to be true. Hence the whole statement will become what? The whole statement will become a true. So in this way you can understand. And if you want to have the visualization of this, so here this is the visualization. The visualization says that first one we are putting into p of 1, and then OR will be there, and then will be p of 2 OR, and then here will be getting p of 3 OR, and here will be getting what? Here will be getting p of 4. So in this manner you can understand p of 1 will become a false, or p of 2 will become a true, or here will get false, or here will get false. So this whole statement turns out to be what? The whole statement turns out to be a true. So whenever someone says that there exists, then you have to consider there exists, inside story of a there exists is always going to be the OR case. The always going to be the OR case. If somebody says that for all, if somebody says that for all, then we have to go and we have to talk about the AND case. So whenever you will have which is nothing but the for all of x, then what you should have? You should have which is nothing but the AND case. Whenever you will have a there exists, then what you have to think? You have to think which is nothing but there is a OR case inside, in between. Okay, so in this manner we can understand the whole concept. Okay, I hope you have understood how, okay, the whole things will be there. Or if you want to understand, let me consider this domain. The domain, as I told you, 1, 2, this is 3, this is 4. Now, if you are writing for all of x, p of x, how it will become this? And if you are writing there exists of x, p of x. So let me tell you the visualization that you people will have. The visualization here you will be getting is basically p of 1, and here you will get p of 2, and here you will get p of 3, and here you will get p of 4. Now, with respect to this, you will be getting p of 1, or you will be getting p of 2, or you will be getting p of 3, or you will be getting p of 4. So this is the visualization that you people will get. Whenever you will have for all of x, p of x, there is a AND inside. Whenever you will be having there exists of x, p of x, then there is a OR case inside. So this is the visualization that you people are getting. Always remember this thing. And basis of that, what we can understand is a negation of a quantifier. So everybody knows that negation of a quantifier. See here, if I'll put a negation, and here if you'll have something like that for all of x, p of x. The first type of doubt the student used to ask me, sir, if you'll put a negation, this is just for a quantifier for whole. Whenever you will have a negation before quantifier, it is for everything. And everybody knows that it is logically equivalent to there exists of x negation of a p of x. Now the student is having a lot of doubt, and then students will be going and will be asking. So let me tell you, suppose if your domain consisting of 4 number of elements, 1, 2 and 3. Now what you can write with respect to this? What you can write with respect to this? You can write which is nothing but P of 1, and here you will be getting P of 2, and here you will be getting P of 3, and here you will be getting P of 4. Now what will happen if you will be putting a negation here? So according to the De Morgan's law, this negation will go inside and it will changes to negation of P of 1 or negation of P of 2, or here you will be getting negation of P of 3 or negation of P of 4. Okay, so basically you will be getting this OR cases. Now consider this as one box, consider this as second box, consider this as third box, consider this as fourth box. There is a OR case, so obviously you will be getting there exist, and then you will be getting negation of P of x. So that's how we can understand the whole particular concept which is related to the negation of a quantifier. I hope everybody has understood. So I have taught you the basic concept of what? The basic concept of a predicate logic. Okay, so I hope you have understood each and every particular concept that is related to there. Okay, so yes, thank you for today. So again, for our next session we will be considering the other things, and that is going to be valuable to all of you. Okay, thank you so much for watching this video, and we'll come up with the another session, and that is related to the predicate logic. Here these all are the faculties that is teaching into the Gradeup, and if you are taking a Gradeup subscription, it will be very beneficial to all of you, and these all are the rankers that we are having. So if you people wants to take a subscription, because the batches are going on, and if you people are thinking that such that if you want to prepare for GATE examination, then you can take a admission by calling on this particular number, and there are many batches are going on, and you can take a admission into some of your batches, and you can help your preparation. Okay, so yes, thank you so much for watching this video. Have a great day to all of you. Thank you.